What if the barren, red wasteland of Mars could one day teem with life, rolling green landscapes, breathable air, and rivers carving through fertile soil? It sounds like pure science fiction, right? But transforming Mars into a second Earth isn't as far-fetched as it might seem. The biggest obstacle: Mars is a planet that's hostile to life as we know it. Freezing temperatures, a thin atmosphere, and a complete lack of ecosystems present challenges that go beyond anything humanity has ever faced. However, this is where the brilliance of advanced technology comes into play. Thanks to breakthroughs in artificial intelligence and biotechnology, we now have the tools to reimagine Mars not as a barren rock, but as a thriving, habitable world. In this video, we're exploring how AI-driven systems and biotech-engineered plants could become the unlikely heroes of Mars terraforming. From creating life-supporting ecosystems to solving problems only a machine could tackle, the possibilities are nothing short of extraordinary. Let's dive into the cutting-edge science that could turn this vision into reality. What happens if Earth can no longer sustain us? It's a question that feels alarmingly less hypothetical with each passing year. Rising sea levels, extreme weather, dwindling resources, and a rapidly growing population are pushing our planet to its limits. Climate change alone threatens to displace entire regions, and as we continue to consume resources faster than they can renew, the urgency to think beyond Earth becomes unavoidable. While our priority should always be preserving and repairing our home planet, we can't ignore the possibility that one day Earth might not be enough. So where do we go next? Mars stands out as the most viable candidate for colonization, and it's not just because of its proximity. Among all the planets in our solar system, Mars shares the most similarities with Earth. It has a day that's only slightly longer than 24 hours, polar ice caps containing water, and seasons that resemble Earth's, albeit more extreme. Mars also has a solid surface and enough gravitational pull to potentially support human life, unlike gas giants or moons with weak gravity. However, let's not sugarcoat it, Mars is still a harsh and unforgiving environment. Its atmosphere is over 95% carbon dioxide with almost no oxygen. The air pressure is so low, stepping outside without protection would be fatal. Add to that freezing temperatures averaging -80 degrees Fahrenheit and the absence of any natural ecosystems. It's clear Mars wasn't designed with human comfort in mind. Yet, despite these challenges, its similarities to Earth make it our best shot. But why does humanity need groundbreaking technologies like artificial intelligence and biotechnology to make this leap? Simply put, the challenges of Mars colonization and terraforming are unlike anything we've dealt with before. On Earth, ecosystems have had billions of years to evolve and support life. Mars, on the other hand, is a blank slate, completely devoid of the natural processes that sustain our existence, like plants producing oxygen or microorganisms breaking down organic matter to enrich soil. If we want to transform this barren landscape into one that resembles Earth, we'll need to engineer solutions from scratch, often working with systems and scales too complex for humans to manage alone. This is where the promise of AI and biotechnology steps in. Artificial intelligence can take on the enormous task of monitoring and regulating environmental conditions across an entire planet. Imagine autonomous systems managing greenhouse structures, balancing oxygen levels, or even identifying and responding to potential threats like dust storms, all without human intervention. And then there's biotechnology, which brings the potential to design plants and microorganisms capable of thriving in Mars's hostile conditions. By engineering life forms that can withstand extreme cold, survive on minimal water, and metabolize carbon dioxide into oxygen, we could jumpstart the processes needed to make Mars livable. The idea of terraforming Mars isn't just about solving a scientific puzzle, it's about ensuring the survival of our species. But the tools we'll need to overcome these hurdles will have to be as advanced and resilient as the challenges themselves. From here, let's explore how these groundbreaking technologies could turn the red planet green, one innovative step at a time. If we're going to turn Mars into a habitable planet, plants are going to be the stars of the show. On Earth, plants are the foundation of almost every ecosystem. They do much more than just look pretty or provide food. They are the machines that convert sunlight into energy, produce oxygen, and recycle carbon dioxide. Without them, life as we know it wouldn't exist. Think about it. When you breathe in oxygen, you owe that life-giving gas largely to the work of plants and other photosynthesizing organisms like algae. Plants also play a critical role in fixing nitrogen, a key ingredient for building proteins, making it available to other organisms in the ecosystem. In many ways, plants are the cornerstone of Earth's biosphere and the reason it supports such a vast diversity of life. Now imagine trying to replicate that magic on Mars, a planet with no life, no soil, and an environment that's actively hostile to anything green. The Martian atmosphere is incredibly thin, less than 1% of Earth's, which means there's very little carbon dioxide for photosynthesis. Temperatures can drop to as low as -200 degrees Fahrenheit at night, and there's no protection from the sun's harsh ultraviolet radiation due to the lack of a magnetic field and atmospheric shielding. And let's not forget the soil, which is full of toxic salts like perchlorates, making it completely unsuitable for Earth-native plants as it is. If you were to plant a seed on Mars today and water it, it wouldn't sprout, it would freeze, suffocate, and essentially get fried by radiation all at once. But even with these challenges, plants remain one of humanity's best bets for transforming Mars into a habitable world. Why? Because they're like nature's multitaskers. If we manage to get plants to take root on Mars, they could not only produce oxygen, but also help regulate the planet's atmosphere by removing excess carbon dioxide. Over time, these processes could create conditions that are more supportive of human life. Additionally, plants could start enriching Mars's barren regolith, slowly building up the kind of nutrient-rich soil needed to sustain agriculture. This would mark the beginning of a self-sustaining ecosystem, a critical step in making Mars livable. Here's where biotechnology comes in. We can't just pack some tomato seeds and hope for the best. Instead, we'll need to re-engineer plants to survive and thrive in Mars's extreme environment. Think of it as designing super plants. Using advancements in genetic engineering, scientists could create plants that are highly resistant to cold, capable of flourishing in low-pressure environments, and more efficient at converting carbon dioxide into oxygen. For instance, researchers are already studying how to incorporate genes from extremophiles organisms that naturally survive in extreme conditions on Earth into plants. These superplants could use significantly less water, tolerate high radiation levels, and even neutralize toxins in the Martian soil. To put this into perspective, consider how Earth's biosphere began. Billions of years ago, our planet's atmosphere was harsh and uninhabitable, dominated by gases that would be toxic to most modern life forms. Then came cyanobacteria, tiny organisms capable of photosynthesis, which began releasing oxygen as a byproduct. Over millions of years, they transformed the atmosphere into one that supported more complex life. By leveraging biotechnology, we could essentially speed up this natural process on Mars, creating plants that act like modern-day cyanobacteria on steroids. But it's not just about survival. The ultimate goal is to build an ecosystem that can support itself with plants as the foundation. They would not only produce oxygen but also provide food and create a stable environment for other life forms, from microorganisms to eventually humans. As we reimagine what plants are capable of, we're essentially rewriting the rules of biology to fit an entirely new world. So, how do we start designing and testing these Mars-ready plants? That's where the intersection of biotechnology, artificial intelligence, and controlled experiments comes into play, which we'll delve into next. Let's explore how we can turn these bold ideas into tangible, life-sustaining systems. Let's take a closer look at the cutting-edge science that could make Martian plants a reality. At the heart of this effort lies biotechnology, a field that allows us to reprogram nature itself. With tools like CRISPR and synthetic biology, scientists are starting to unlock the secrets of life at a molecular level, manipulating DNA to create organisms that can overcome challenges far beyond what evolution on Earth has prepared them for. On Mars, this means designing plants that can survive in extreme cold, tolerate intense radiation, and flourish in an atmosphere that's almost entirely carbon dioxide. Essentially, these would be plants engineered not just to survive, but to actively transform Mars into a more Earth-like environment. CRISPR, which stands for Clustered Regularly Interspaced Short Palindromic Repeats, is one of the most powerful tools in this endeavor. It's often described as molecular scissors for DNA. It allows scientists to make highly precise edits to the genetic code of a living organism. By identifying and altering specific genes, we can give plants traits that would be impossible through natural breeding alone. For example, researchers could introduce genes from extremophiles microorganisms that already thrive in some of Earth's harshest environments into plants. These genes might enable a plant to withstand freezing temperatures, endure high levels of ultraviolet radiation, or even metabolize Martian regolith, which is rich in toxic salts like perchlorates. CRISPR makes this kind of gene transfer faster, more accurate, and more accessible than ever before. Imagine a plant that could thrive in the thin Martian atmosphere, where carbon dioxide makes up over 95% of the air. On Earth, plants already use carbon dioxide for photosynthesis, but atmospheric conditions here provide plenty of oxygen and nitrogen to balance the process. By engineering plants specifically for Mars, scientists could amplify their ability to capture and convert carbon dioxide into oxygen. This wouldn't just be beneficial for humans, it could also help build an atmosphere that supports other forms of life. To see the potential of such advancements, let's look at a few real-world examples. Scientists have already created frost-resistant plants by introducing genes from Arctic organisms that produce antifreeze proteins. These proteins help plants survive sub-zero temperatures by preventing ice crystals from forming inside their cells. On Mars, where temperatures can plummet to hundreds of degrees below freezing, such a trait could be a game-changer. Similarly, algae, a simple yet incredibly versatile life form, has been engineered to thrive in extreme environments like deserts and even outer space. Some strains have been bioengineered to grow using minimal water and under high radiation, features that would make them ideal candidates for Martian agriculture. Algae could serve multiple purposes on Mars, producing oxygen, providing biofuel, and even acting as a food source. Synthetic biology takes this a step further by designing entirely new biological systems from scratch rather than modifying existing ones. Using this approach, scientists could create plants with custom-tailored traits programmed into their DNA. Imagine a fast-growing, radiation-resistant plant that not only produces oxygen but also secretes compounds to neutralize the toxic salts found in Martian soil. Over time, such plants could help convert the barren regolith into fertile soil capable of supporting more diverse life forms. Synthetic biology also allows for modular designs, meaning plants can be engineered to perform multiple functions simultaneously, like stabilizing soil while producing food and oxygen. But the implications go beyond just survival. This kind of technology could help kickstart a self-sustaining ecosystem. Once introduced, these engineered plants could begin to shape their environment, setting off a cascade of changes that move Mars closer to habitability. By converting carbon dioxide into oxygen, they could slowly thicken the atmosphere, reducing temperature extremes and paving the way for other organisms to follow. This process wouldn't happen overnight, but it would be a monumental step toward terraforming Mars. Of course, engineering these Martian plants isn't without its challenges. Scientists need to ensure that these organisms won't mutate in unexpected ways or create ecological imbalances. Rigorous testing in simulated Martian environments will be crucial to refining their designs and minimizing risks. Still, the progress we've already made in genetic engineering and synthetic biology gives us reason to believe this vision is within reach. By combining the precision of CRISPR, the creativity of synthetic biology, and our growing understanding of extremophile organisms, we're engineering life to do something extraordinary, make Mars habitable. Up next, we'll explore how artificial intelligence comes into play, not just to help design these plants, but to manage entire ecosystems on a planet that's over 100 million miles away. Stay tuned as we uncover how machines and biology work together in this incredible endeavor. If biotechnology provides the tools to engineer life for Mars, artificial intelligence acts as the brain behind the operation, driving the process with unprecedented precision and efficiency. While genetic engineering has opened the door to creating plants tailored for Mars's extreme conditions, it's the unique capabilities of AI that make it possible to navigate the complexity of this challenge. Imagine trying to design a plant that can thrive in an environment so alien that no natural life form has ever encountered it. The variables are staggering, from the harsh radiation levels to the toxic soil composition to the freezing temperatures. This is where AI steps in, acting as a powerful partner in solving problems that would be overwhelming for human researchers alone. Let's start with genetic research. Engineering plants for Mars isn't as simple as editing one or two genes. Each plant trait, like cold resistance or increased photosynthesis efficiency, can involve dozens, if not hundreds, of genetic pathways. AI algorithms are uniquely suited to sift through this complexity. By analyzing massive amounts of genetic data, AI can uncover which gene combinations would optimize a plant's ability to survive on Mars. For example, imagine AI examining billions of genetic possibilities to determine which traits from Earth's extremophile organisms that thrive in conditions like Antarctica or deep-sea hydrothermal vents could be transferred into plants. Without AI, this type of research could take decades. With it, researchers can run simulations and achieve breakthroughs in a fraction of the time. But the role of AI doesn't stop at identifying useful genes. After traits are selected, AI can predict how a genetically engineered plant is likely to perform under Martian conditions. For example, AI models can simulate how a plant might respond to the thin air on Mars, which contains 95% carbon dioxide but almost no oxygen. These simulations provide critical insights before experiments even begin, saving time and resources by narrowing down which designs are most promising. Think of AI as a master chess player. It looks at the entire board, considers every possible move, and predicts the outcomes several steps ahead, all before committing to action. In the same way, it predicts how plants will survive, grow, and adapt in an environment as challenging as Mars. To make this even more relatable, consider how AI is already revolutionizing agriculture here on Earth. Farmers now use AI systems to monitor soil health, track weather patterns, and even predict crop yields with stunning accuracy. These systems analyze enormous datasets, enabling smarter decision-making and maximizing efficiency. On Mars, AI could do something similar but on an entirely new level. By analyzing soil samples from the Martian surface, for example, AI could determine what changes are needed to make the regolith suitable for plant growth. It could then guide experiments in real time, adjusting variables like nutrient levels or temperature to improve success rates. Essentially, AI becomes the ultimate lab assistant, capable of processing data and making adjustments far beyond human capability. Here's an analogy. If biotechnology is the raw creative force reshaping life, AI is the architect overseeing the process. It's the system that connects millions of data points, identifies patterns invisible to the human eye, and ensures that each step builds toward a larger goal. Without AI, the process of engineering plants for Mars could feel like trying to put together a puzzle with half the pieces missing. But with AI, researchers can see the full picture, identifying the gaps and predicting the outcomes with remarkable clarity. The beauty of AI in this context lies in its adaptability. It's not limited to just one aspect of the Mars terraforming mission. Beyond genetic research, AI could manage the deployment of these engineered plants across Martian landscapes. It could monitor their growth, analyze their impact on the surrounding environment, and adjust planting strategies to ensure the ecosystem develops as planned. For example, if radiation levels in a certain area prove too high, AI could suggest relocating crops to a safer zone, all while continuously learning and improving its decisions over time. By acting as the brain behind the biotech revolution, artificial intelligence isn't just making Mars terraforming possible, it's making it efficient, scalable, and sustainable. The combination of AI's analytical power and biotechnology's creative potential gives humanity a real shot at transforming the red planet into a world that can support life. Up next, let's explore how AI could manage entire ecosystems remotely, building and sustaining life on a planet over 100 million miles away. Smart greenhouses might just be the perfect bridge between barren Martian soil and thriving ecosystems. Picture this: in the midst of Mars's dusty red landscape, a translucent dome gleams under the pale sunlight. Inside, rows of vibrant green plants flourish, their tubular leaves and engineered roots adapting to an environment that would otherwise be uninhabitable. These are no ordinary greenhouses, these are AI-powered habitats designed to do what has never been done before: nurture and sustain life on a planet that wants nothing to grow. The concept of a smart greenhouse goes far beyond simply covering plants with a protective shell. On Earth, greenhouses help regulate basic factors like temperature and humidity, creating a controlled environment for plants to thrive despite external conditions. On Mars, smart greenhouses take this concept and amplify it with cutting-edge artificial intelligence, essentially transforming these structures into self-contained life support systems. The stakes are unimaginably high. Every variable, from the intensity of light to the chemical composition of the soil, has to be carefully balanced to give engineered plants the best chance at survival. Let's break it down. Temperature might be the most obvious challenge. Mars can swing from highs of around 70 degrees Fahrenheit during the day to lows approaching negative 200 degrees Fahrenheit at night. No earthly plant, even the most genetically modified one, can handle those extremes. Smart greenhouses powered by AI can address this by constantly monitoring internal temperatures and adjusting heating systems in real time to maintain optimal growing conditions. But it's not just about keeping the greenhouse warm, it's about finding the right balance. Too much heat and the plants might wilt, too little and they might freeze. AI systems can analyze temperature fluctuations in Mars's environment and preemptively counteract them, ensuring a stable climate for plant growth. The same principle applies to light. Because Mars is farther from the Sun, it receives less sunlight than Earth, and the light it does get is filtered through an atmosphere filled with dust particles. Smart greenhouses can be equipped with artificial lighting systems that mimic sunlight, providing the specific wavelengths that plants need for photosynthesis. AI would manage these lighting systems with pinpoint precision, adjusting intensity and timing to match the plant's growth cycles. As a result, even on a planet with dimmer sunlight, plants could photosynthesize as effectively as they do on Earth. Humidity and water management are another monumental challenge. Mars's air is extremely dry, making it nearly impossible to retain moisture naturally. AI systems could automate irrigation processes, using just the right amount of water to hydrate the plants without wasting a single drop, a crucial consideration given how scarce water is on Mars. In fact, these systems could recycle water vapor released by the plants themselves, capturing it and reintroducing it into the irrigation system. This closed-loop water cycle would ensure that every molecule of water is used as efficiently as possible, a necessity for survival in such a resource-limited environment. And then there's the soil, or more accurately, the regolith. Mars's surface isn't soil as we know it. It's a mixture of fine dust and jagged particles filled with toxic salts like perchlorates. Plants, even genetically engineered ones, need specific nutrients to grow, and that means the regolith would have to be carefully treated. Smart greenhouses could integrate AI systems to monitor soil composition continuously, detecting deficiencies or imbalances in nutrients and dispensing fertilizers or neutralizing toxins as needed. Over time, these efforts could help transform small patches of Mars's regolith into something resembling fertile soil, one greenhouse at a time. What makes AI indispensable in this setting is its ability to manage these countless variables simultaneously. Unlike human operators who might only be able to focus on one factor at a time, AI systems can evaluate the entire environment in real time, optimizing every aspect of the greenhouse to work in harmony. For example, if AI detects that a plant is receiving slightly more light than it needs, it could immediately lower the artificial lighting intensity while simultaneously adjusting water and nutrient levels to compensate for any added stress on the plant. This level of precision is vital for resource management on Mars, where every watt of energy and every ounce of water counts. In many ways, smart greenhouses would serve as controlled experiment testbeds to refine our techniques for growing life on Mars. Before we attempt large-scale terraforming, we need to perfect the art of growing plants in smaller, manageable environments. These greenhouses would allow scientists to study how engineered plants interact with Martian conditions, tweak their designs, and gradually scale up their efforts. They are quite literally the seeds of Mars's transformation. By combining the power of biotechnology with the precision of AI, smart greenhouses represent the first step in creating an autonomous food supply on Mars. But their significance goes beyond agriculture. They are proof of concept evidence that life can take root on a planet that once seemed utterly inhospitable. And as these greenhouses become increasingly advanced, they could pave the way for building ecosystems that stretch beyond their glass walls, turning pockets of greenery into the first chapters of Mars's rebirth. While the dream of terraforming Mars may feel like a distant science fiction vision, the groundwork for this monumental leap is already being laid here on Earth and even in space. Scientists, engineers, and visionaries are conducting real-world experiments and developing technologies that could eventually make life on the red planet a reality. From advanced agricultural systems to ambitious space travel missions, these projects are bridging the gap between possibility and practicality, showing us that the future of Mars colonization might not be as far off as we think. Take NASA experiments with growing plants in simulated Martian soil, for example. For years, NASA has been working to understand how we might cultivate crops on Mars using a soil substitute that mimics the unique chemical and physical properties of Martian regolith. This regolith, loaded with toxic perchlorates and lacking organic nutrients, poses a serious challenge for agriculture. Yet, researchers have successfully managed to grow certain plants, such as radishes, peas, and lettuce, in this simulated Martian soil by supplementing it with nutrients and carefully monitoring its composition. These experiments are not just theoretical, they provide critical insights into how plants might be adapted to survive in extraterrestrial environments. Every radish grown in a lab represents progress toward establishing a sustainable food source on Mars. Another groundbreaking effort is happening aboard the International Space Station. Astronauts have been growing plants in zero-gravity conditions to study how they adapt to environments vastly different from Earth's. The veggie experiment, for instance, has successfully grown edible plants like lettuce and zinnias in space, paving the way for future crop cultivation on long-duration space missions. These experiments are testing the fundamental biological processes that plants rely on, such as water absorption, nutrient uptake, and growth cycles, in environments that mimic the challenges of Mars. Meanwhile, SpaceX is tackling the problem from a different angle, not just how to grow food on Mars, but how to get humanity there in the first place. Under the leadership of Elon Musk, SpaceX has developed the Starship program, a fully reusable spacecraft designed for interplanetary travel. Musk's vision is audacious. He wants to establish a self-sustaining colony on Mars, starting with cargo missions and eventually transporting thousands of people. While this goal might seem overly ambitious, the milestones SpaceX has already achieved, such as successful orbital launches and landings, demonstrate that the company is actively turning science fiction into engineering reality. But what's particularly exciting is how many of the technologies being developed for Earth are also contributing to Mars readiness. Take the concept of smart farms, which are already revolutionizing agriculture here at home. These high-tech farming systems use artificial intelligence, precision sensors, and automated machinery to monitor and optimize every aspect of crop production. For instance, AI can analyze soil health in real time, adjust irrigation systems to conserve water, and predict the exact nutrient needs of plants. These innovations are invaluable for food production in arid or resource-limited regions on Earth, but they also provide a blueprint for how agriculture on Mars could work. In fact, some researchers have begun testing these smart farming systems under Mars-like conditions, such as Arctic deserts or volcanic soil, to see how they perform in extreme environments. And then there's biotechnology. Companies like Bayer and Syngenta are leading the charge in genetically engineering crops that are more resilient to harsh climates, require less water, and can grow in less fertile soils. These advancements are solving pressing agricultural challenges on Earth, but are also directly applicable to Mars. Imagine a future where scientists engineer crops capable of thriving in Martian regolith, producing both food and oxygen while requiring minimal human intervention. Every breakthrough in biotech here moves us closer to creating life-supporting ecosystems on Mars. What ties all of these projects together, whether they're focused on growing a single radish in simulated Martian soil or building spacecraft for interplanetary travel, is the sense of urgency and innovation. The challenges are immense, but so is the progress. Together, these efforts are transforming what was once the realm of imagination into tangible, actionable steps toward a future where Mars could be humanity's second home. And the work happening today is setting the foundation for one of the most ambitious endeavors in human history, turning Mars from a barren rock into a thriving world. As we stand on the brink of transforming Mars into a habitable planet, an important question looms over this monumental endeavor. Do we have the right to alter an alien world? While the prospect of terraforming Mars inspires hope and ambition, it also raises profound ethical and environmental dilemmas that demand careful consideration. Mars has existed as a barren, lifeless planet for billions of years. Changing it into a world that suits human needs may seem like progress, but at what cost? And more importantly, how do we ensure we don't repeat the mistakes we've made on Earth in our quest to colonize another planet? One of the core ethical questions is whether humanity should even attempt to terraform Mars in the first place. Mars is pristine in a way that Earth hasn't been for millennia. It's untouched by human activity, a blank slate that holds clues about the origins of our solar system and perhaps even life itself. By altering its landscape, we risk erasing that history forever. Furthermore, if we were to discover microbial life on Mars, no matter how simple or primitive our actions could threaten or even destroy it. Do we have the moral authority to prioritize human needs over the potential for preserving an alien ecosystem, even one that might seem insignificant to us? Would interfering with Mars's natural state make us stewards of the planet, or would it make us invaders? There's also the question of unintended consequences. History has taught us that even well-meaning interventions in natural systems often have unforeseen effects, many of them harmful. On Earth, introducing non-native species to new environments has frequently led to ecological disasters. Just think about invasive species like the cane toad in Australia or kudzu vines in the United States, which have disrupted local ecosystems in ways no one anticipated. Now imagine the stakes when we're dealing with an entire planet. The plants and microorganisms we introduce to Mars might not behave as expected. They could mutate in ways we can't predict, potentially creating harmful ecosystems that we're unable to control. Without fully understanding the long-term consequences, do we risk creating problems on Mars that outpace our ability to solve them? This is where artificial intelligence becomes an essential tool, not just for terraforming, but for safeguarding against potential environmental risks. AI can simulate complex planet-scale scenarios in ways that human minds simply can't. By modeling the long-term effects of introducing certain plants, microbes, or atmospheric changes, AI can help us predict and mitigate unintended outcomes before they occur. For example, algorithms could simulate how genetically engineered plants might interact with Martian soil over decades or even centuries, ensuring they don't trigger harmful chain reactions. AI could also monitor the gradual transformation of Mars's environment in real time, identifying early signs of ecological imbalance and suggesting corrective actions. In short, AI offers us a way to approach Mars terraforming with caution and foresight, minimizing the likelihood of catastrophic mistakes. Still, we must confront the broader philosophical question of responsibility. As we look to Mars, we carry the knowledge of how human activity has altered the Earth, often for the worse. Climate change, deforestation, pollution, and biodiversity loss are just a few examples of the consequences of prioritizing short-term gains over long-term sustainability. Do we want to carry these same tendencies to another planet? Or does this endeavor offer humanity a chance to reflect on its role as a species and embrace a greater sense of accountability? If we decide to terraform Mars, it shouldn't just be about creating a backup plan for Earth. It should also be about learning to be better stewards of the worlds we touch, starting with our own. The ethical and environmental considerations aren't meant to discourage us from pursuing the dream of Mars colonization. Instead, they underscore the importance of approaching this endeavor with humility, caution, and respect. Mars represents an incredible opportunity, not just to expand humanity's horizons, but to prove that we can learn from our past. If we take the time to anticipate the consequences, make decisions grounded in science, and uphold a commitment to preserving Mars's natural beauty as much as possible, we might build something extraordinary, a future on Mars that reflects the best of what humanity can achieve. Terraforming Mars is without a doubt one of the most ambitious undertakings humanity has ever imagined, but let's be clear, it's no simple feat. While the idea of creating a habitable, Earth-like environment on the red planet is inspiring, the challenges ahead are monumental, forcing us to rethink nearly every aspect of science, technology, and logistics. From transporting the necessary equipment to sustaining life over decades or even centuries, the road to Mars is fraught with obstacles that demand solutions as innovative as they are bold. To begin with, let's talk about transportation. Mars isn't just around the corner. On average, it's about 140 million miles away, depending on its position relative to Earth. That means every piece of equipment, every engineered seed, every ounce of water has to be launched into space and safely delivered to its destination. But launching cargo into orbit is expensive, mind-bendingly expensive. Even with technological advancements like reusable rockets pioneered by companies like SpaceX, the cost of transporting biotech labs, smart greenhouses, and everything else we'd need to terraform Mars remains astronomically high. And then there's the issue of space. A rocket can only carry so much, meaning every shipment must be carefully planned down to the last gram to maximize efficiency. Could we eventually build factories or bioengineering facilities on Mars itself to eliminate the need for constant resupply from Earth? Possibly, but we're far from that reality today. Once we've managed to deliver our equipment, there's the issue of sustaining life, not just for months, but for the many years it would take to make Mars habitable. Keeping astronauts alive on a planet with no breathable air, no liquid water, and no food is a logistical challenge unlike anything humanity has ever attempted. Even the International Space Station, which orbits just a few hundred miles above Earth, relies heavily on supply missions. On Mars, resupply missions would take months to arrive, and any delay or error along the way could be catastrophic. This is where AI could play a critical role, autonomously monitoring life support systems, rationing resources, and identifying problems early enough to implement solutions. For instance, imagine an AI system detecting a drop in oxygen production in a smart greenhouse and automatically adjusting the balance of carbon dioxide and water to stabilize it without waiting for human intervention. But Mars itself presents its own unpredictable set of problems. The planet is infamous for its dust storms, some of which can grow large enough to engulf the entire planet for weeks at a time. These storms block sunlight, a critical energy source for both solar panels and photosynthetic processes in plants. They can also damage sensitive equipment, further complicating efforts to maintain stability. AI systems, once again, can help mitigate these risks by predicting storm patterns and preparing equipment and habitats for prolonged periods of low power or reduced light. For example, an autonomous system could initiate energy-saving protocols or redistribute power to critical systems during a storm, ensuring the survival of plants and humans alike. Then there's the matter of Martian weather and its extreme conditions. Temperatures can vary wildly, dropping to deadly lows at night and creating a hostile environment for anything that isn't perfectly insulated. Gravity, too, could pose long-term challenges. At just 38% of Earth's gravity, it's unclear how this will affect plants, animals, or even the human body over extended periods. Will plants grow differently? Will radiation exposure, which is far higher on Mars due to its thin atmosphere, cause unforeseen genetic mutations in our engineered organisms? These are questions we can't fully answer yet, and they highlight just how much remains unknown about terraforming Mars. That's where continued innovation in biotech comes into play. Scientists are constantly refining techniques to address these uncertainties, developing hardier crops and more adaptable biological systems to overcome the unforeseen obstacles that are sure to arise. Ultimately, the combination of artificial intelligence and biotechnology gives us a fighting chance against these challenges. AI's analytical capabilities allow us to run millions of simulations to anticipate and solve problems before they arise, while biotech ensures our life-sustaining systems are as efficient and resilient as possible. Together, these technologies form a powerful partnership capable of tackling the vast unknowns of Mars. Which brings us to the ultimate question: how far are we from making this vision a reality? Can we overcome these immense challenges within our lifetimes, or is Mars terraforming a multi-generational mission? As we look ahead to the future, the answer is closer than you might think, but it will demand levels of cooperation, innovation, and persistence that humanity has never achieved before. As we come to the end of this incredible journey, let's take a moment to reflect on what we've explored. Terraforming Mars, a dream once confined to the realm of science fiction, is steadily stepping into the realm of possibility. At the heart of this vision lies a powerful partnership between artificial intelligence and biotechnology. Together, these groundbreaking technologies form the backbone of humanity's efforts to turn Mars into a habitable world. AI provides the precision and foresight to solve complex planetary challenges, while biotech gives us the ability to reshape life itself, designing plants and ecosystems capable of thriving where none have ever existed before. This synergy has the potential to transform humanity's future. Imagine a Mars where genetically engineered plants produce breathable oxygen, where AI-powered greenhouses support thriving ecosystems, and where generations of humans live and work on a planet that was once a barren wasteland. This isn't just about creating a second home for humanity. It's about pushing the boundaries of what we're capable of and proving that even the most daunting obstacles can be overcome with innovation, determination, and collaboration. But here's the most exciting part: this vision isn't some distant fantasy. It's rooted in the technologies we're building today, the tools used to engineer crops that survive in the harshest climates on Earth, the AI systems managing precision agriculture, and the breakthroughs in space exploration all show that we're taking tangible steps toward this extraordinary goal. Every lab experiment, every rocket launch, every line of code contributes to a future where humans may one day walk on a green Mars under a breathable sky, a future where we've not only survived but thrived beyond our home planet. As we look to the stars, it's impossible to ignore the deeper significance of this endeavor. Terraforming Mars isn't just about adapting another planet to suit our needs. It's about adapting ourselves, evolving our understanding of life, and taking on the responsibility that comes with such power. It's about learning from our past here on Earth to create a future where humanity flourishes in harmony with the environments we shape. Mars represents the next great chapter in our story, one that will test our creativity, resilience, and willingness to dream big. Now we want to hear from you. What excites you most about the idea of terraforming Mars? Do you see it as humanity's next frontier, or do you think we should focus on addressing challenges here on Earth first? Let us know your thoughts in the comments, and if you're as fascinated by this topic as we are, don't forget to like this video, subscribe to our channel, and share it with others who love exploring the possibilities of science and technology. Together, we can inspire more people to join the conversation and support the innovations shaping our future. The dream of a habitable Mars reminds us of one essential truth, that the limits we face today are only temporary. With every step forward in science and technology, we're proving that we have the creativity and determination to overcome them. So, let's keep dreaming, keep pushing, and keep exploring, because the future isn't something we wait for. It's something we build.